Hey guys, today we are going to do the next section. It's 8.3.2. It's going to involve some applications or story problems, if you will, that involve either the law of sines or the law of cosines. So the same formulas we've been using, so keep those formulas handy. But these are going to be in some word problems, and we're going to have to make a decision about which of the formulas we should use. Okay, so first example here has to do with what you have is you've got two Coast Guard stations, and you've got this ship that's out to sea that sends like an SOS signal. Okay, now these two stations are far apart from each other. Okay, if you read the problem, it says you got station Zulu. It's located 120 miles due west of station X-ray. So here's X-ray, here's Zulu. They are 120 miles from each other. So they look like they're really close in the picture. That's just for the sake of the picture, but they're really, really far apart. Okay, and this ship is out to sea, and these two stations can't really see it. Okay, it's far enough out to where, like, the curvature of the Earth, you wouldn't be able to see the top of that ship. So here's what's happening. A ship sends an SOS call that is received by each station. Now, the call to station Zulu indicates the bearing of the ship. So bearing has to do with, this is a nautical term, this information right here, north 40 east. It means if you stare at like 40, or at north, okay? So look north and then rotate 40 degrees to the east. So you're looking this way and then you turn 40 degrees. That's the direction the signal is coming from. That's all they can tell is what direction it's from, but they can't see the ship. Station X-ray indicates they're getting the signal from north 30 west. So that's 30 degrees west of north. So face north and then rotate 30 degrees towards the west. Okay, north, south, east, west. And then that's the direction they're getting it from. Okay, so here's what we've got. What we're trying to figure out is how far is each station from the ship, and then whichever one of the stations is closer, they're the one who's going to send help. They have like helicopter and they can send it out there. All right, so here's what we've got. Notice it looks like we don't have enough information, but if you notice, this is north and this is east. This is a 90-degree angle. So if we know that this angle is 40, that means this angle is 50, because they have to add up to 90. If I know this angle over here is 30, then that means this angle right here would be 60. And remember, whenever you have two angles in a triangle, you automatically have the third angle as well. So I've got 50 and 60, that's 110. These all need to add up to 180. So this is a 70-degree angle. Okay, I put it right on top of the letter C right there. Maybe I shouldn't have. Okay, that is a 70-degree angle. And that 70 is across from the 120 that they gave us. This is a match. Okay, this is the angle and the side that are across from each other. So as soon as we know that we have a match, we know that we can use the law of sines to solve this problem. So let's do that. So we're going to find this distance right here. This is A. So we're going to use the sine of 70 over 120. Okay, there's the match that I had. And then that is equal to the sine of, well, 50 is the angle that's across from A. So 50 over A. And then we're going to set up another, we're going to use the same given information, the sine of 70 over 120. And then we're going to set that equal to, okay, so we're going to find side B, that's across from 60. So the sine of 60 over B. And now we're going to plug these into our calculator and remember, we're going to cross multiply and divide. So 120 times, so the two that are diagonal from each other, sine of 50 equals, leave that in your calculator, don't round it yet, divided by the sine of 70, and we get 97.8. So A is 97.8. Now that would be miles. Don't worry about labeling it. Okay, on the test, we're not going to make you label, so just worry about getting that number right. Okay, so that's 97.8, and then you're going to do the same to B. So go ahead and do B. I will do it too. And you should get B to be like 110.6. Okay, so there's your two distances, and that's all you were asked to find on this problem. So in this story problem, A is shorter than B, so X-ray is the one who's going to send help because they're closer and it'll get there faster. Okay? All right, next problem, number 2. All right, so here's what's going on. We've got a motorized sailboat leaves Naples, Florida. So here's Naples, Florida. This is the bottom of Florida. This is Naples. Bound for Key West. So here's those islands that are to the south of Florida. This is Key West, which is 150 miles away. So that's the straight distance between Naples and Key West. It's 150 miles. Maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents, the crew finds that after 4 hours that the sailboat is off course by 20 degrees. So they did not go straight towards Key West. They were going off course at 20 degrees. Now, they were going 15 miles per hour for 4 hours, which means they covered a total of 60 miles. And if you look at the picture, they went ahead and labeled that for us. So here's what we've got. Okay? So, the question is, how far is the sailboat from Key West right now? So here's our boat. Here's Key West. What is this distance right here? Now, in this triangle, you're going to see some extra variables. You're going to see a theta here. You're going to see an A right here. There's more parts to this question that we've taught in the past, but this is all I need you to know today is, can you find this distance between the boat and Key West? So this is the third side of our triangle. So here's the variable we're looking for. We're trying to find this side X. The angle across from it is the 20 degrees. Now remember, this would be our match. Okay, if you were going to use like the law of sines, this would be your match right here, the angle on the side across from it. But we don't know this. We don't know that side. So we do not have a match. So this is a law of cosine problem. So that's what we're going to do. Now, it's one of the law of cosine problems where we're trying to find a side. So we're trying to find this x squared, and you could call that A, which would mean the angle across from it would be big A, or you could call that little c. But the variable doesn't matter. Just know that that variable and that angle, that's what we're going to start, and then we're also going to finish the formula with that 20 right there. Okay? So the 60 and the 150, those are the other two sides that go into the formula. So it's 60 squared plus 150 squared, and then it's minus 2 times 60 times 150 times the cosine of our angle, which was 20 degrees. Now, this is one of those where the variable is already on the other side. These are nothing but numbers, so you can plug these all into your calculator in one step. Okay, so 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of 20. Put all that in there. Again, make sure your calculator is in degrees. I've had some messages from students that had it in radians. That's this little button right here that'll change from degrees to radians. Okay, so I'm going to hit that. I'm going to hit equals. Now, that's my x squared. So x squared is 9,185.532,826. That's what my calculator says. Don't round this yet. Okay, go ahead and leave that exact answer in your calculator. Now we're going to take the square root. So we need to know what x is. So the square root of our answer. And we get 95. So now we want to round. So 95.8. So weighting as long as you can. Wait until your last step to round, and that'll make sure you don't get a rounding error in the middle of your question. Okay? All right, this last one we need to draw a picture. So, Major League Baseball diamond is actually a square. If you're looking at a baseball diamond, it's actually a square that's kind of at an angle. Okay? Knowing it's a square is going to be important in this problem, because that tells us that all of these angles are 90 degrees. Okay? And it's 90 feet on each side. So the distance from like home plate to first base is 90 feet. The pitching rubber, there's a little piece of rubber here that the pitcher has to put his foot on when he throws the ball. The pitching rubber is 60.5 feet from home plate. All right, so there's the rubber. There's home plate. And that is 60.5. So we know this distance and we know this distance. How far is the pitching rubber to first base? So what is this distance? Okay, so we know. So we've got a triangle. We've got two sides of the triangle, and we're trying to find this side over here. Well, we know one more thing. This angle right here, if these are squares, if these are all 90 degrees, then this square just got cut in half. Not this one. This one. This is a straight line that runs straight down the middle, so this is 45 degrees. So now we can do this problem. Again, I'm trying to find a missing side. I know the angle that's across from us. That would be the match, but we don't know one of those matches. So this is not a law of sine problem. This is a law of cosine. Okay, so I'm trying to find x. I know these two sides, and I know this angle. Why don't you press pause, see if you can set this up, and then complete the problem from here on out to figure out the length of that side right there. All right, so here's my work. So here's where I plugged everything in. So I was trying to find the side that's across from the 45-degree angle, so those should be on the ends of my formula. Here's my other two sides. The variable I wanted is all by itself over here, so I plugged all that into my calculator and got this. This is the exact reading on my calculator. You have to write this down. Just leave it in your calculator, then take the square root of that value, and this is what you should get now rounded to the nearest tenth, 63.7. And that's it. If you take a look at your worksheet, there are 4 problems that I want you to try on your own. I'll give you a hint. 2 of them are going to be the law of cosines and 2 of them are going to be the law of sines, but you've got to make that decision. All right, thanks.